Do you know, long back people used wood and coal as the main fuel, but they released lot of smoke and pollute the environment. And it is also quite difficult as well as inconvenient to handle them. So what could have been the solution then? Well, have you heard about CNG and LPG? Well, they both are the cleanest fuel of fossil fuel. They are less polluting, non-corrosive in nature, and can also be sent through pipes very easily. Now, what is LPG and CNG made up of? Well, LPG is a liquefied petroleum gas and CNG is a compressed natural gas, and both are hydrocarbons. That is, compound of carbon and hydrogen. LPG is a mixture of butane and propane, whereas CNG is made up of methane, which are both hydrocarbons. Now, let's discuss more about hydrocarbons. Hydrocarbons can be classified into three main categories. One is saturated hydrocarbon and unsaturated hydrocarbon, or arenes. In saturated hydrocarbon, hydrocarbons, carbon-carbon atoms and carbon-hydrogen atoms are held together by a single bond. They are together and they are known as alkanes. In case of unsaturated hydrocarbon, these compounds consist of a double bond or a triple bond between carbon-carbon atoms. The double bonded compounds are called alkenes, whereas the triple bonded compounds are known as alkynes. Whereas in arenes, the compound consists of at least one aromatic ring. In this video, we will discuss about alkanes. So, alkanes are unsaturated hydrocarbon with general formula CnH2n plus 2. Alkanes are also called paraffins. Para means little and affinity means reactive. Methane, which is the first member of this family, followed by ethane, propane, butane, etc. Now, let's discuss the structure of alkane. Carbon atoms involved in molecules of alkane are sp3 hybridized, and all the bonds, whether carbon-carbon or carbon-hydrogen, are sigma bonded. Moreover, the carbon atom are tetrahedral in nature and the respective bond angles are the same as in a regular tetrahedron, that is 109.5 degree. However, it is not so convenient to represent every time a molecule of alkane by three-dimensional structure. Thus, a planar representation is used. The first three alkanes, that is methane, ethane and propane, have one structure. But if you see higher alkanes, they have more than one structure. Let's discuss the structure of butane. Here, the 4 carbon atoms of C4H10 can be joined either by a straight chain or with a branch chain. So, butane can be represented by N-butane and isobutane, which is 2-methyl-propane. Both the structure possess same molecular formula but differ in their boiling point. Therefore, they are chain isomers of butane. Now, do you know in how many ways we can join 5 carbon atoms and 12 hydrogen atoms of C5H12? Well, pentane with a molecular formula C5H12 can be represented as N-pentane, that is pentane, and isopentane, which is 2-methyl-butane, and neopentane, which is 2,2-dimethyl-propane. Again, all three structures possess the same molecular formula but differs in their boiling point. Therefore, they are chain isomers of pentane. The carbon atoms in alkanes are classified as primary, which is 1 degree carbon atom, secondary, which is 2 degree carbon atom, tertiary, which is 3 degree carbon atom, and quaternary, which is 4 degree carbon atom. It depends upon whether the carbon atom is linked to 1, 2, 3 or 4 carbon atoms. The terminal carbon atoms are always primary. Carbon attached to 2 carbon atoms are known as secondary. tertiary carbon is attached to 3 different carbon atoms and neo or quaternary carbon is attached to 4 different carbon atoms. Now, let us discuss the general IUPAC nomenclature of alkanes. First is to find the name of the longest continuous carbon chain. Second is to identify and name the group attached to this chain. Third, number the chain consecutively starting from the end to the nearest substituent group. Fourth is to designate the location of each substituent group by an appropriate number and name. Fifth is to assemble the name listing group in alphabetical order. Let's try to name a few compounds. Here, the parent chain has 6 carbon atoms and 2 alkyl group present on the parent chain. So, the position numbers are arranged in an alphabetical order. Thus, the name of this compound will be 4-ethyl 2-methyl hexane. Now, let's see how we can write the correct structure from the given IUPAC name. Let's try to make the structure of 3-ethyl 2,2-dimethyl pentane. This can be done by a given steps. First is to draw the chain of 5 carbon atoms, then give numbers to the 5 carbon atoms. Then attach the ethyl group at carbon 3 and 2-methyl group at carbon 2. Then satisfy the valence of each carbon atom by putting requisite number of hydrogen atoms. Thus, we arrive to a correct structure. Now, let's discuss the preparation of alkane. Alkane can be prepared from unsaturated hydrocarbons, from alkyl halide and from carboxylic acid. Let's discuss each of them in detail. Alkane can be prepared by the hydrogenation of unsaturated hydrocarbon, that is alkene or alkyne. This can be done by reacting hydrogen and the hydrocarbon over the surface of a catalyst, that is finely divided nickel or platinum at 525 to 575 Kelvin. But there is one limitation, that is we cannot prepare methane by this method. Alkyl halide can be converted to alkanes in a number of ways. One of them is by reduction with zinc and hydrochloric acid. The other method by which alkyl halide can be converted to alkane is on treated with sodium metal in dry ethereal solution. This reaction is known as Wood's reaction and is used for the preparation of higher alkanes containing even number of carbon atoms. Now, let's discuss the next method from carboxylic acids. Sodium salt of carboxylic acid on heating with soda lime, that is a mixture of sodium hydroxide and calcium oxide, gives an alkane containing 1 carbon atom less than the carboxylic acid. This process of elimination of carbon dioxide from carboxylic acid is known as decarboxylation. Well, the other method is Klopf's electrolysis method. In this method, a concentrated aqueous solution of sodium or potassium salt of monocarboxylic acid is electrolyzed to form alkanes containing even number of carbon atoms. The reaction is supposed to follow the following path. At cathode, the electron accepting tendency of hydrogen ion is more, and these are discharged in preference to sodium ion, which remains in the solution. At anode, the electron releasing tendency of acetate ion is more, and these are discharged in preference to hydroxide ions. Thus, alkanes and carbon dioxide are evolved at anode, while hydrogen at cathode. However, this method also have few drawbacks. One of them is methane cannot be prepared by this method, and alkanes with only even number of carbon atoms can be formed using this method. Now, we have come to an end of this session. Can you write the product as a result of Wood's reaction when a mixture of neopentyl bromide reacts with isobutyl bromide? Well, try to figure out the answer. Now, let's summarize what we have learned so far.
Manorama Horizon. Learning made simple.